All right, before we get to looking at your net for your rectangular prism, let's talk about a prism just in general a little bit. A prism has two bases. That are parallel and congruent. So if you're ever unsure of what the base of a prism is, double check for yourself that they are parallel and congruent. Okay? A lot of you think that whatever it's sitting on is the base, and that is absolutely not true. The bases have to be parallel and congruent. It is not necessarily just whatever side it's sitting on. Okay? The other faces are what we call the lateral faces. So similar to that lateral surface of a cylinder, the other non-base sides are the lateral faces. All right, so we're going to do some work developing our surface. So a little more simply, surface area will be 2 times the capital B. That capital B represents the area of the base plus capital P times H. Again, that capital B is area of the base. The capital P is perimeter of the base. So those capital letters mean something specific. All right, we have a couple of straightforward examples here. The first one is a rectangular prism. What I like to do is this. Take your highlighter on Notability and highlight your bases. And again, for a rectangular prism, you could pick a couple different things to be your bases. I'm just going to pick the top and bottom that it's sitting on, but you could choose different ones for the base. Start with your formula. On this app, it hides my tool. Okay, and then what we're going to do is we are going to find the area and the perimeter of the base kind of separately. So off to the side, I have a capital B, I have a capital P. We are not going to do all of this in one step. Trust me, you will mess up. Off to the side, we're finding area of the base. What figure is this base? A rectangle. So the area of a rectangle is length times width. What is the length and the width of our base? All right, so 10 times 5, the area of our base is 50. Now we can take that measure and plug it into our surface area formula. So we have 2 times the area of the base, which we now know is 50. All right, next thing we need is the perimeter of our base. Carrie said 30. How did you get the perimeter is 30?
10 plus 10 plus 5 plus 5.
10 plus 10 plus 5 plus 5 is 30 indeed. Now again, once you have that measure, now you can take it and plug it into your surface area formula. How about 30 instead of 20, like he told me? And then this H is height of the prism. What is the height of the prism, Taylor? 6. That's the distance between your two bases. Once you have all those values plugged in, now it's just a calculator issue. 2 times 50 is 100. 30 times 6 is 180. Add those together. The surface area is 200. What are the units? Inches squared. So for this triangular prism, this becomes a lot more difficult when we're finding the area of the base. That's the part that gets pretty tricky here, especially because we don't know the height of the base. All right, so what I want you to do, start off the same way. Start off with your surface area formula. We have a couple of things to find. We need to find the area of the base, the perimeter of the base, I can't erase that. And then the one thing that we do know right away is the height of the prism. What is that? What is it? Nope. The height of the prism, 5, is always the distance between the bases. So again, highlight your bases. Those are the two triangles. It's not what it's sitting on. It's a lot of what people think. It's not what it's sitting on. It's actually those two triangles. Okay? All right, so off to the side, we need to look at finding the area of the base and the perimeter of the base. One of these is not too bad. Finding the perimeter of this base is not too bad. We know all three sides. So the perimeter is just going to be 7 plus 7 plus 7, which is 21. Once we have that perimeter, you can go ahead and plug that into your surface area formula if you want. But we have some work to do on finding the area of that triangle. Have some work to do on finding the area of that triangle. All right, first of all, what is the formula to find the area of a triangle? Taylor?
Half the base times the height.
All right, half of the base times the height. What is the base of the triangle? 7, okay. What's the height of that triangle? No. No.
Oh, you have to find it.
We have to find it. Yes, we have to find it. The height of that triangle is from the... we have to draw that height straight down. That does make a 30, 60, 90. So this would be... So if this is a 30, 60, 90 right here, I know that if the hypotenuse is 7, that short leg will be 3.5, but what we really are needing is the height, which is the long leg. So how could we find that? We could use Pythagorean theorem, or we could do what?
Wouldn't it be 3.5 radical 3?
It would be 3.5 radical 3. For our purposes here, go ahead and just multiply that out. So on your calculator, 3.5 times the square root of 3. Let me know what you get. 6 point what? 6 point... What is it? 6 point what? 6.06. Okay, awesome. 6.06. Now that we have the height of that triangle, now we can actually calculate the area of that triangle. So the 6.06 times 7 times 1/2 is what? What is that? 21.21. Now we can take that, put it back in our surface area formula, and multiply. All right. This should be, what, 42.42 plus 105, which is what? 147.42. Make sure you have meters squared. So think about volume again, kind of how we thought about it last time for a cylinder. What will affect the volume of a prism?
Shape.
What do you mean shape?
Like.
Shape of what?
The figure.
Okay, shape of the figure. Shape of what else will affect it?
Base.
Definitely the shape of the base. What else will affect the volume of a prism?
Height.
The height. This is very similar to a cylinder, where the height matters and then the shape and the area of that base, just like the area of the circle for the cylinder mattered. So this is going to look pretty similar to the cylinder volume formula. It's the area of the base. We keep it general for this because the base could be a triangle, it could be a rectangle, it could be a lot of different things. So we're going to keep it general and just say the area of the base and then times whatever the height is. So if you look at the first example, again, we'll start with the formula. Make sure that I'm seeing everything that you're doing in your work. And then again, off to the side, we will find the area of the base. Don't try to do this all in one line or one step. So the first thing we need to think about, what figure is the base?
It's all the same. So.
It is all the same. It's a cube. So the base would be a square. Area of a square is side squared. Where the side length of the square is 8. So the area of our base is 64. We can take that, plug it into our surface area formula. And then what is the height of the prism? 8. 64 times 8 is what? 5 what?
12.
I have all sorts of mistakes on my notes. I have 520. And I wrote that. 512. I believe you. And what are the units? Inches cubed. Very good. Let's look at this next one. Again, we have a triangular prism. What are the bases here? The top and bottom triangles. This one's a little bit easier than the last one, though, because we actually do know the base and the height of the triangle. So finding the area of our base is a little bit nicer on this one. So start with your volume formula, area of the base times the height of the prism. Off to the side, let's find the area of the base. Because our base is a triangle, area is going to be 1/2 base times height. What is the base of the triangle? What is, no, we don't. Nope. What is the base of the triangle? 3. And what is the height of the triangle? 4, exactly. The area of the base is 6, so we can take that, we can plug it in. And then the height of the prism, again, is the distance between the bases, which is 2. 12 centimeters cubed. We'll do this last example, and then I'll let you go. I think that should do us okay for today. Working backwards a little bit, we're solving for y, which if you look at that in terms of the prism, that is the height of the prism. Given the surface area is 870. So start with your surface area formula, and we'll work this similar to how we did this type of problem with the cylinder. Fill in what we know and then solve. So we can substitute that 870 in for surface area. What are some other things that we know or that we could find to fill in that formula?
The base.
What do you mean the base?
So can't you just put like 2 and then in parentheses like the 12?
No. Guys, what does the capital B mean? Area of the base. Okay. That capital B means something specific. Well, can I find the area of the base? Okay. Well, Carrie, what's the area of the base?
Half 12 times 5.
1/2 times 5 times 12. Good. Which is what?
30.
30. So now I know the area of the base. Now I can fill that in to the capital B. Anything else that we know or that we could find? What does the capital P mean?
Oh, I meant the height.
Oh, okay. Yes, we could replace the H for height with the Y. I still need, however, the perimeter of the base. Maddie? Yep, we would have to use Pythagorean theorem to find that hypotenuse, and then we could add them together. Or if you know a few Pythagorean triples, you might already know what the hypotenuse is. If not, 5 squared plus 12 squared equals c squared. You could certainly do it that way. What is it? 30. 30?
13.
The hypotenuse should be 13.
Oh,
You're ahead of me?
I just went on that.
Yeah, the length of the hypotenuse is 13, so then the perimeter would be 12 plus 13 plus 5, which is 30. We can simplify a little bit at this point, so 870 equals 60 plus 30y. Then it's just algebra from here. Subtract the 60 and divide by 30. And we get that the height is 27 meters.